Welcome back everyone to the video lecture series on flexible bodies. For the sake of convenience, I have merged the third and the fourth video together so that the full exercise demo is covered in one video only. So now, let me begin with the exercise demo. So click on the Flex Tools option and then the Flex Prep option to invoke the Flex Prep dialog box. Now, you can leave the first option as it is because we are creating the OptiStruct PRP file and we're also generating the H3D flex body file. So we'll keep the first option as it is. Next, we need to load the .fem file, that is the FEA file that we want to convert into the flex body. So let's load our .fem file. So it's in chapter 12. So first, let's work with the left lower control arm. So I'll select this file sla flexleft.fem. So this gets loaded in. Now, let me go to the fourth option. Here, I will be saving the file, my flex body file as sla flex left. I'll call it test1 and the file extension will be .h3d. So then I hit save. So I want to keep the component mode synthesis method as Craig-Bampton method, and then for the next option I want to specify the interface nodes. So for my model the interface nodes are 4887, and if you can remember I had mentioned that we need to separate the interface nodes with the plus symbol. So I'll be separating the interface nodes with the plus symbol. So the first interface node is 4887. The second one is 4888 and the next one is 4890. And the next option, which is the cutoff type and the value, I'll leave it as it is. Okay, so this is the maximum modes requested by the user, so I leave this as 15, and by default the solver mode is Lanczos, and I will leave the rest of the options as it is. So I'll go to the additional options and I will check on the perform stress recovery and also the perform strain recovery options in order to get the stress and strain results for the body. Then I close this. Now, I hope you all remember what I told you in the previous video. We need to convert all the RBE3 spiders into RBE2 spiders. So let me just click on this particular option which says create RBE2 spiders. So when you click this, hypermesh will be invoked on the fly. Okay, so we can see that happening now. Let's give it some time. Yes, so it took you directly to the hypermesh GUI. Okay, so first thing what we need to do here is go to this particular option which says user profile. Okay, and we need to select this as OptiStruct and say OK. So once we do that, and now if we zoom in, we can see that this is RBE2 spider. So no problem with that. Now we need to create an RBE2 spider here. So we come here and click on the utility tab and then the user tab here. So and then click on the super spider and select one of the nodes here and say proceed. So automatically we get a RBE2 spider that's created at this particular interface node. Next, then we need to convert them into RBE2 spiders. So let's check what the spiders are. So let's go to the card edit and then change this particular option to elements. And then select these elements, say edit. So what does it say? RBE3 here. So these, or the spider is basically it's an RBE3 spider. Okay, so we need to convert this to RBE2. Now let me check with the other spider that we have here. So again, go to the same option, card edit, click on these elements, say edit. These are RBE2. So this is all fine. So what we need to do is we need to convert these elements from RB3 to RB2 before doing anything with our flex body. Okay, so still keep in mind, this is not a flex body, it's just the OptiStruct file. It's a .fem file, and once we run our flex prep utility, we'll be getting the .htd file. So this is just a pre-processing part of it. Okay, now I'll be converting the RB3 spider into RB2 spider. So please concentrate on how I do that. So click on the 1D option here. Okay, the 1D radio button basically. Now you can go to config edit option here and select these elements, and then click on new config and select rigid link as the option, and then you can hit on switch button. So this means that the RB3 spider has been converted to RB2 spider. Now you return and you can check that. So go to the same option, which is the card edit option here, and click on the spider and then say edit. So you can see that it is converted to the RB2 spider. So now we're all set. So once this is done, you can just say save and close. So you can save this particular file as capital SLA flex left test1.fem. Okay, so yeah, it will be saving it in .fem format itself, so no need to worry about that. Okay, so once it gets saved, I think you guys observe that it directly came back to motion view. Okay, so now that's done. So now we should continue with the process to build our flexible body. So I'm just checking once again if the additional options, these two options are checked, and yes, these two options are checked to perform stress recovery and also the strain recovery. Okay, now let's close this and say okay. So OptiStruct runs in the background to generate the flexible body. Okay, so it generates this particular report, which means that, and it says end of report, and we don't see any errors. So it has successfully completed converting the .fem file to the .htd file, which is nothing but converting the FE model into the flex body. Say okay. Now what you can do is just switch to hyperview. So if you want to just take a look at the flex body, just click on hyperview and load that model. Okay, so this is the SLA flex left test1.htd. So you've loaded the model, and these are the interface nodes that you can see on the screen. Okay, and now let me just do a contour plot. So here we have displacement, stress and strain. Okay, so let me just select displacement and say apply, and here are the different modes and the frequencies. So let me just select a particular mode, and I will set this particular option to set modal animation, and then click play. So I'm just reducing the speed of the animation. So you can see that the maximum displacement at this particular frequency happens in this region. Okay, so this is your flexible lower control arm, and this is on the left hand side of suspension. Okay, now let's just go back to motion view. Okay, so now we've generated the left lower control arm. So now what we have to do is we need to again use the flex prep utility to basically mirror the left lower control arm and generate the right lower control arm. So for that we need to select the second option, or the second radio button, which says translation of flexible body files. So here select the second option, which says mirror existing HTD flex body, and then here you need to specify the original HTD file. So you need to click on the folder option here and then go back to the same location. Okay, so we have our first flexible body file here, which is on the left hand side of the suspension. So we take this as the original file, say open, and then specify the mirrored H3D file name. So the one you want to mirror it as. So we need to change from left to right, right? So just click on this particular option, select the same file, but make sure that you change from left to right. Okay, then hit save, and you will be mirroring it across the XZ plane. Okay, and then say okay, and it's done. So instead of again creating the whole flex body for the right lower control arm, this is how simple it is in motion view using the flex prep utility. You have the left lower control arm, you just have to mirror it across a particular plane, which is the XZ plane in this case, to get the right lower control arm. And now say okay. And now what we'll do is we'll just go to the model option here, assembly wizard. So this I'm doing to get the suspension system, the built-in suspension system that's available in motion view library. So first I will load in that, and it has a rigid lower control arms. So I'll be loading in this particular model. So I'll be selecting the front end only, then hit on next option, and then say no driveline, select next. Here I'll be changing the suspension system to front SLA suspension one piece LCA. So make sure you change from the default MacPherson suspension to the third option here. Okay, then click on next, next, again next. So you can leave these options as it is, and then again click on next. So here leave the compliant option as yes, and then say finish. So you got this suspension system from the motion view model library. Okay, and you can see that, so these are the lower control arms, the red bars that you can see, these are the lower control arms. Okay, and these are now rigid bodies. Okay, they're modeled as rigid bodies. So what we'll be doing is, we already have a flexible body files, so we'll be replacing these rigid body files with the flexible body, and then we'll be running our analysis. Okay, and the analysis that we'll be running will be a static ride analysis. So go to the analysis option, select the task wizard, and here for the task or the type of analysis, we'll be selecting the static ride analysis, say next, and then finish. So you can leave all these parameters as it is, next, finish. Okay, so you got this particular test rig for the static ride analysis. Now your only job is to replace these rigid lower control arms with the flexible lower control arms that you just created. Okay, so for that you can just expand the front SLA suspension, this particular model, expand that, and under that you can expand the bodies, and under the bodies you can go to lower control arm. So this highlights the lower control arms. Now what you can do is, it's already in properties, uncheck the symmetric properties, and you get this particular dialog box. Okay, so for, when you get this particular dialog box, say retain the values. So just hit on retain. So it retained the values for the left hand side and the right hand side. And now check this flex body option. So it asks you whether you want both the sides to be deformable. So yeah, you want both the left and the right lower control arms to be deformable or flexible bodies. So hit on yes. Okay, so you're on the left hand side now. So you need to basically load in the flexible body file, which is nothing but the .h3d file for the left lower control arm. So click on this folder option. So you have these two flex bodies available. So click on the SLA flex left and say open, so that it gets loaded in. And once you get this, just click on the notes. Why I do that is because you can see that the model is just brought in, the flex body is just brought in, but it is not connected yet. Okay, so for that you need to basically put a check mark on this particular option which says only search for interface nodes. Make sure only this is checked and then hit on find all. Okay, so it finds all the interface nodes, and then you can see that it is offset by this distance. So then you can say align all, and you'll get a particular warning message saying, are you sure that you want to move the listed entities? Say yes. So when you do that, you can see that you can close this now. So you can see that it is now perfectly connected to the suspension system.